This is part 26 of LINQ tutorial. In this video, we'll discuss set operators in LINQ. All of these standard query operators belong to set operators category. In this video, we'll discuss the distinct operator. Distinct operator returns distinct elements from a given collection. Let's look at an example. Here we have got countries string array. Notice that we've got USA twice and UK twice. Now when we invoke a distinct method on this countries array, we get this output. Notice that within the output UK is retrieved only once, but USA is present twice. Why is that? That's because in this case the default comparer is being used, and the comparison here is case sensitive. As a result of that, it's going to see USA in capital letters as a different entry from USA that's present in small letters. Now if we want this comparison to be case insensitive, then what we can do is use the other overloaded version of this distinct method, to which we can pass a class that implements IEqualityComparer as an argument. So notice the example here, it's very identical to what we have here, but we are using the other overloaded version of the distinct method, to which we are passing string comparer as an argument to this distinct method. Let's actually look at this in action. So I have this exact same code already typed within the main method. So now first of all, notice that we have two overloaded versions of this distinct method. At the moment, we're using the one which does not take any parameters. So here, the default comparer will be used to compare the strings. And the default comparer, when it compares strings, it's going to be taking into consideration the case sensitiveness. That's why it treats these two strings differently. Okay, so when we run this, look at that, USA is printed twice. Now we don't want that default comparer to be used, so what I'm going to do is I'm going to use this distinct overloaded version, to which we can pass a type that implements IEqualityComparer. So this class string comparer actually implements IEqualityComparer interface. So if I right click on that and then go to the definition, notice that this class implements IEqualityComparer. Now if you look at this IEqualityComparer, within this there are two methods that we need to override, equals and get hash code. So this class implements those two methods. So now the comparison in this case is going to be case insensitive, and as a result of that, within the output, notice that we get USA also only once. Now when comparing elements, distinct works in a slightly different manner with complex types like employee, customer, invoice, orders, etc. Let's actually look at an example. So at the moment, within our console application, we also have a class called employee class, and this class at the moment contains two properties, ID and name. So what we are going to do here is, notice that we are creating a list of employees. At the moment we have got 3 employees, and within the list, notice that Mike is repeated twice. And then on the list we are invoking the distinct extension method, and when we run this, notice that what we get in the output, Mike is actually printed 2 times. Okay, so it's not retrieving the distinct elements. Why is that? Again, here the default comparer is being used, and this default comparer, when it's comparing reference types, all it does is check whether if the reference of this object is equal to the reference of this object. Now in this case the references are different. Why? They are two new employee objects. Though the individual property values are the same, the object references are different. That's why it treats those objects differently. So to speed things up, I have actually typed this code in the notepad already. So let's copy that and then let's paste that within our main method. So again, here we have those 3 employees, and we are invoking the distinct method, and then we are using a for each loop and then printing the ID and the name of each employee. So when we run this, look at that, Mike is repeated twice, and we don't want that. Okay, so how to correct this problem? Actually, there are 3 ways to correct this problem. One of the ways is to use the other overloaded version of the distinct method, to which we can pass a custom class that implements IEqualityComparer. Okay, so what we can do here is create another class we can call it employee comparer or give it any meaningful name, and then make that class implement IEqualityComparer interface. And then we have just seen that within IEqualityComparer interface there are two methods that we need to implement. One is equals and get hashcode methods. So let's go ahead and do that. So to this project, let's add a new class and let's call this employee comparer. And we are going to make this class implement IEqualityComparer interface, IEqualityComparer of employee. Okay, and I'm going to click on this and then press Control dot, so it will give us the option to implement the interface IEqualityComparer. So the moment I select that option, notice that we have to implement these two methods that are present within this interface. So first of all, we need to tell when two employee objects are considered to be equal. Now whenever the ID and name property of one object equal to the other object properties, then we know those objects are said to be equal. So what I'm going to do is return x.id equals y.id and x.name equals y.name. So if these two conditions are equal, then those two objects are equal. Now if we override equals method, we also need to override get hashcode. Otherwise, when we use these objects within a dictionary, they wouldn't work as expected. Okay, so always make sure when you override equals, you are also overriding get hashcode method. And what we are going to do here is return object dot id dot get hashcode, and then we use this symbol, and then object dot name dot get hashcode. Okay, so that's the first step. So we implement we write a class that implements IEqualityComparer interface and then provide implementation for these two methods. Once that is done, the next step is to actually pass that as an argument to the distinct method. Okay, so since we have two overloaded versions of this distinct method, we are now going to use the other overloaded version, and we are going to pass an instance of our employee comparer class. Now let's run this and notice that within the output we get Mike only once. Okay, so that's our first option. The second way to solve this problem is to override equals and get hashcode methods in employee class. Now first of all, let's get rid of this parameter here. Now when we run this, we'll have the same problem. Now the other way to solve that is within the employee class, we override equals and get hashcode methods. So now the distinct method knows when two employee objects are said to be equal and when they are not said to be equal, right? So first let's override the equals method. So override equals. So when do we consider two objects of this type employee are said to be equal? Whenever return this dot id equals to whatever object that we are passing to this method. Now employee. So if the ID of the incoming object is equal to the ID of an instance of this class, and similarly name property of this instance equal to the name property of the incoming employee object. So that's when we consider two employee objects to be equal. Now since we are overriding equals method, we also need to override get hashcode method. So return this dot id dot get hashcode and this dot name dot get hashcode. Okay, now notice that we are using the version of the distinct method that doesn't take any parameters. But now since we have overridden equals and get hash code, now distinct method knows how to compare two employee objects for equality. So when we run this, look at in the output, we get what we expect. Okay, so that's the second way to solve the problem. The third way is to actually project the properties of the employee object into a new anonymous type. And behind the scenes, anonymous types override equals and get hash code methods, so we get the output that we expect. So the simple way to solve that problem is we don't have to override these two methods here, or we don't even have to provide this custom class that tells how to compare two employee objects. The simplest way is to simply project the properties of the employee object into a new anonymous type. So new x.id and x.name. Now look at this. So we have commented this one within the overridden methods within the employee class, and here we are projecting each employee object into an anonymous type, and anonymous types automatically override equals and get hash code methods. So when we run this, we should get mic only once. Okay, so this is the easiest way to solve the problem. That's it for today. Thank you for listening. Have a great day.